Like I said yesterday we were going to talk about relations. Today we're going to talk about functions. So we're still in chapter 3, section 1. So today will mainly be about functions. Okay, I got a little visual up here for you guys. Thinking about the mail system. Can I have one letter go into a mailbox?
Yes.
Yes. It's perfectly acceptable, right? Can I have multiple letters going into one different mailbox? Yes, right? You can get multiple pieces of mail, right? Can I have one piece of mail, the same exact piece of mail, without tearing it in half or anything like that, going to two different mailboxes? No. Only one piece of mail can only go to one mailbox, right? It can't go to multiple mailboxes. Keep that in mind as we're talking about our functions today. Because here's what the definition of a function is. A function is a relation in which each element in the domain, what is my domain? From yesterday? My set of x values, right? So a relation in which each element in the domain, aka my x values, is paired with exactly one element in the range. What's my range? Y values, right? My set of y values. So, in other words, in the parentheses right here, a function does not repeat an x value, and the graph must pass the vertical line test. So if we go back to our little visual here, think of the letters as the x values, and the mailboxes as the y values. For it to be a function, I cannot have the same x value, the same piece of mail, going to two or more different y values, or mailboxes. Does that make sense? So for it to be a function, each x value only has one y value. Okay? I'll give you time to write this. So an example here we have this relation. A relation is just a set of ordered pairs, right? So we have 1, 2, 2, 3, 4, 3, 5, 6. Would this be a function or not a function? I know the answer is already up there. But what would it be? Function or not a function? Function, and why is that the case? Yeah, no x values repeat. What are my x values in this case? 1, 2, 4, and 5. None of those are repeating. I don't have the same x value anywhere in there, so I know this is a function. Does that make sense? Okay, second example, you could probably guess that is probably not going to be a function, but what are my x values here? 2. 1, 1, 2, 2. So I have a few x values repeating there, so that would not be a function because it has an x value that repeats. Are we getting the gist of what a function is and what a relation that is not a function is? Function has no repeating x values. Are we okay with that? Okay. Can I move on, or do I need to wait a little longer? Okay, I'll wait a little longer. And we'll talk about this vertical line test here in a little bit. Function does not repeat an x value, and the graph must pass the vertical line test. Am I good to go ahead and move on? Okay. Here's the vertical line test. The vertical line test. A graph is a function if a vertical line does not intersect more than once. If a vertical line would intersect more than once, the graph is not a function. So, let me kind of give you a visual of that. Got the graph of a line right here. I'm going to take an imaginary vertical line. So I like to use my pencil as my vertical line. Vertical is up and down, right? So if I drag my vertical line across this graph and pretend that the vertical line goes on forever and ever in all directions. If I drag this vertical line across my graph, how many points on this line is it going to hit at a time? Just one, right? Right here, it's just hitting 1 point, correct? If I drag it to the right a little more, it's only going to still be hitting 1 point. Does everyone see that? Is it ever going to hit more than 1 point at the same time? No. So this would be considered a function because it passes my vertical line test. Okay? Let me give you another example here. There's this little shape that I graphed up here. Drag my vertical line across. Is that ever going to hit more than 1 point at a single time? Yes. Right now, it is currently hitting at this point and this point on the graph when I drag my vertical line across, correct? So this would not be a function because it does not pass my vertical line test. So everyone getting the idea of what I'm meaning here? About hitting 1 point at a time versus multiple points at a time. Everyone okay with that? One more here real quick. Would this graph pass the vertical line test, do you think? This is kind of angled up to the left and up. This one's kind of angled up and to the right. So do you think that passes the vertical line test or no?
Yes.
Yes. So this would also be a function. If it passes the vertical line test, it is a function. If it does not pass the vertical line test, it's not a function. And here's why that's the case. Let's say this point is -2, 3. Well, this point is probably going to, since this is a vertical line, it's going to have the same x value, correct? -2, -3. So, because it's on the same x value, that means it has a repeating x value. And for a function, do we want a repeating x value? No, that's why the vertical line test works. Okay? Are there any questions about the vertical line test? All right, can I move on? Okay, I want you to start looking over this for a little bit. Go through on your own and put the letter of each thing up here under function or not a function. Does that make sense? So letter A. Most of the time when we have a table of values, our x value is the top row, y values are the bottom row. So number 1, do I have any or letter A, do I have any repeating x values? No, so is that a function or not a function? Function, so you'd put letter A under your function column. Does that make sense? And just to clarify on a few of these, letter C, we have a typo here. This y value is supposed to be a 6. Okay? And then letter K, these y values are all supposed to be different. And on our graphs, sorry the graphs aren't the best, they're hand drawn on there. But this graph right here on M is kind of going up and to the right. Okay? Same thing with this one on O. These sides are supposed to be going up and to the right. Okay, any questions on what we're doing? Go through and determine what you think is a function or not a function. Put that letter in the whatever column you think it is. Here in about 5 or so minutes, we'll go over it. All right, let's go over this. Letter A, we already said was a function, correct? Does everyone understand why A is a function? Has no repeating x values, so I know it's a function. What did we put for letter B, and why did we put it? What did we put for letter B? Or where did we put letter B?
Function.
Function. Why did we put function?
Because it doesn't have repeating x values.
No repeating x values. Very good. Letter C. What do we say about letter C?
Not a function.
Not a function. Why is it not a function? What x value is repeating? 5. Got that repeating x value of 5, so I know it's not a function. Letter D. Not a function. I only have one x value, and it's repeating multiple times. Any questions on our first row of our table of values? Okay. Let's look at our mappings now. Letter E, what do we say? Function or not a function on letter E? Function. Each x value is only mapping to one y value, right? So I know that one's a function. What about letter F? There's no numbers on there, but it's the same concept, right? I've got x values on the left, y values on the right. Does each x value only go to one y value? Does each x value only go to one y value? Yeah, right? This one only goes to 1, this one only goes to 1, this one only goes to 1, this one only goes to 1. Is it okay to have a repeating y value? Yeah, we only care about the repeating x values for function versus not a function. So this one is a function. Any questions on that one? What about letter G? Function or not a function? Why is it not a function? What x value would be repeating here? 8. Remember, this is kind of like our visual about the mail earlier. Say 8 is a single letter. We can't have it going to 2 separate mailboxes, can we? No, so this one's not a function. Any questions on G? And what about H? Not a function. Both 1 and 5 are both repeating x values. Any questions about any of our mappings being functions or not functions? We good with that row? Okay, our sets of ordered pairs. Letter I, function or not a function? Do we have an x value repeating? We do not, so this one would be a function. My x values are 4, 2, 1, 10, and 0. None of those repeat, so it is a function. What about letter J? Not a function. I have one x value repeating multiple times. What about letter K? Not a function. Multiple x values repeating. 6, 6, 6, 5, 5. What about L? function. There's only two ordered pairs here, but do I have any x values repeating? Nope, so I know this is a function. Any questions about our sets of ordered pairs? All right, how do we feel about the graphs? How do I test a graph to see if it's a function or not a function? A vertical line test, right? So, like I said, it may be a little difficult since these are hand drawn on here. But what do we say on M? Function or not a function? That one is a function. That curve on the right is going up and to the right, so it's got a slight tilt to it. So my vertical line will only hit 1 point at a time on that graph. Okay, so that one is a function. It passes the vertical line test. Letter N should have hopefully been pretty easy. What's letter N? Not a function. It hits multiple points at one time if I drag that vertical line across, so it fails the vertical line test. What do we say on O? What? Function. It's only going to hit 1 point at a time as I drag that line across. Letter P is a little tricky. What do we say on letter P? What? Not a function. I would agree with that. The graph of this line is a vertical line, right? So if I drag my vertical line across, is it hitting more than 1 point at a time? Yeah, it's hitting all my points at the same exact time, isn't it? So it fails the vertical line test. It's not a function. Any questions on our graphs being function or not a function? Okay. This one was probably a little tricky on letter Q. What do we say on letter Q? And why did we say it? What do we say on letter Q? Function or not a function? Did anyone answer this one? Someone take a guess for me? Function, why'd you say function? Is that just you guessing? Okay. It is a function. I want to throw this one on here. If you were to graph this one, it would just be a line. Does that line pass the vertical line test? Yes, it does, so it's a function. I know that one's tricky. We haven't covered those really, but I wanted y'all to think about it a little bit. And then letter R, function or not a function? Function. Everyone good with that? If y'all had the handout, I would have had you create your own function and create your own non-function. You could create a table of values, a mapping, set of ordered pairs, or a graph. As long as it's a graph and it passes the vertical line test, it's a function. On any of these others, as long as it doesn't repeat an x value, it's a function. For your non-function, just have it repeat an x value, and you got your non-function. Are we understanding the gist of function versus non-function? All right, can I move on? Here's all our answers that we just went over. Okay? We good? All right. So we talked about domain and range a little bit yesterday, correct? Once again, what is my domain? My set of x values. Sometimes we call those inputs. And what's my range? My set of y values. We can call those our outputs as well. Either way. Domain is my set of x values. Range is my set of y values. You should have that in your notes from yesterday, probably. So yesterday, we had a graph that just had multiple ordered pairs on it, right? And we just listed our x values and listed our y values of those ordered pairs to find our domain and range. Okay? Here, it gives us a full graph, and it wants us to find the domain and range. Remember, I want you to write it in set builder notation. Domain equals the set of all real numbers x, such that yesterday we put x equals and we just listed our x values, correct? So, my domain is my set of x values. What x values help make up this blue curve right here? Can anyone help me figure that out? Say what? -4 is definitely one of them. 2 is definitely an x value that makes up this blue curve. -2 is an x value that helps make up this blue curve. 0. 1. What? -1. -3. Right? What about these blue sections between these points that we've already set up here? Are those a part of my curve as well? Are those do those have x values with them? Yeah. Like -1.5. -1.999999999. 1.1111111. I've got an infinite number of x values here making up this curve, right? Because I have all those small little fractions between my whole numbers and my integers, right? So I need to figure out a way to represent all of these x values and cover the whole range of x values. Okay? So, I'm going to show you how to do that for this first one, and then I'm going to have you guys try to help me with my y values. What's my smallest x value here? Do I have a smallest x value? And remember, we're thinking horizontally because that's our x-axis, correct? -4. Does everyone see that that's my smallest x value? Because the graph is stopping at that point. Does everyone see that? What's my largest x value? 2. Because it's stopping at this point, correct? If it had an arrow, that would mean that graph goes on forever in that direction, but it just has a point, so it's just stopping at that point. Does everyone understand that? So, how I represent the domain here is I want all values that are bigger than -4 and smaller than 2. Does that sound familiar from last chapter? What did we talk about last chapter? Inequalities. More specifically in 2.5, we talked about compound inequalities, right? So if I want it to meet two requirements at the same exact time, is that going to be an and or? And, right? It's got to be greater than -4 and less than 2. So, this is how I'd write it. Are these open or closed circles on -4 and 2? Closed. So are they included or not included? They're included, so I have to put the line underneath my inequality symbols. There would be my domain. So domain equals the set of all real numbers x such that -4 is less than or equal to x is less than or equal to 2. So I know my x values must be greater than or equal to -4 and less than or equal to 2 at the same exact time. Are there any questions how I got that? Okay, let's try the range now. Range is my set of what? Y values. So it's going to be kind of the same case here. Can I erase all my points and my dotted lines? Now we're looking vertically because that's our y values. So what's my smallest y value here? Being represented by the blue curve. Say what? Now -4, that was my smallest x value. We're looking vertically now, right? So what's the lowest number on the y-axis this blue curve hits? 2, right? This is the smallest it hits. Does everyone agree with that? What's the largest number y value that our graph hits? 6. So it's going to kind of be the same thing. I'm going to have a compound inequality here to represent all my values between 2 and 6. Does that make sense? So what would it look like here for my range? If I need my y values to be greater than 2 or equal to, and less than or equal to 6 at the same time. Two is less than or equal to y. It's less than or equal to 6. And there would be my range. I know my y values need to be greater than or equal to 2 and less than or equal to 6 at the same time. Be okay with that? Can I move on to my next example? Very similar type problem here. It wants me to find the domain and range of this graph. So, my x values, my domain, I'm looking horizontally from left to right. Does this graph go the same direction forever and ever and ever? Or does it have stopping points? Yeah, it stops here and here, right? So what's my smallest x value represented by the graph? 2. Right there, correct? What's my largest x value? 7, right? 1, 2, 3, 4, 5, 6, 7. Yeah. So, my x values need to be greater than 2 and less than 7. So how would I write that as an inequality for my domain? And think about if these are open or closed circles here.
Would it be 2 is less than y? I mean x.
X, yep.
And then greater than 7? Oh, less than 7.
Less than 7. Because I want x to be greater than 2, correct? So if I read it from the variable standpoint, it's x is greater than 2, correct? And I want it to be less than 7. So it's between 2 and 7. Are 2 and 7 included? No, because they have these open circles on the endpoints. Everyone good with that domain? Okay, now we're looking at our range. We're looking vertically. Looking at the y values here. What y values help make up my range here? What's my smallest y value represented by the graph? 1. Everyone see that? Is 1 included? It's got an open circle on it, correct? So I know 1's not included. What's my largest y value? 6. Is 6 included? No, it's got that open circle on it. So how would I write this in inequality form?
Is less than y is less than 6.
There you go. 1 is less than y is less than 6. We okay with that? Domain and range can be a little difficult at times. It's kind of confusing. Just think about domain being all the x values represented by this graph. And the range, think about it as all the y values being represented by the graph. Okay? Last one here, and then I'm done. Do we have a line or a curve here, or just a bunch of ordered pairs? Just a bunch of ordered pairs, right? So is it going to be some inequality that's representing my domain and range? No, I'm going to be able to list just my x values and just my y values like we did yesterday. Okay? So first off, what would I call this ordered pair? What would the ordered pair be? This one right here. Negative 2, comma 3, because I go left 2, up 3 to get to it. What would this ordered pair be? 1, comma 4. What about this one right here? Negative 2, comma 1. This one here? 3, 1. And this one here? 0, negative 3. So, how many x values do I have total? 5, right? Well, 4, because one of them repeats, right? So, here, like we said, we can just list our x values. So I can just say x equals, what are the x values? Negative 2, 1, 3, and 0. Everyone okay with that? And then for the range, I can just do the same thing. My y values, I can just list them. What are my y values here? 3, 4, 1, and negative 3. There's my domain and range. Everyone okay with that? Real quick, would this be a function or not a function? Not a function because we got a negative or a repeating x value of negative 2. Would this one be a function or not a function? Function, why? It passes the vertical line test, meaning there's no repeating x values. Function or not a function? It would be a function because this one does also pass the vertical line test. Are there any questions about any of our notes for today? Okay, no assignment today. We'll get the assignment tomorrow in class.